Let's begin the session now. The screen is shared to you. I hope for everyone it is visible. So today in this session, we are going to discuss about the parsers. To design any parser, whether it is a top-down or bottom-up parser, we have to practice two functions. One is how to find the first set, and another one is to find the follow set. So that is what we are going to practice in this class today. Before that, I just want you to remind a few things. I hope you know what are the two types of parsers. One is top-down and another one is bottom-up. In the beginning, we are going to concentrate on top-down parsers. Already one top-down parser is discussed in the previous class, which is recursive descent parser, which involves backtracking. Next, we are going to discuss about a new type of parser, which is LL1 parser. This design of parser does not involve backtracking, right? So to design any type of parser, we have to know the first and follow function. Before that, just try to answer me these questions. I want you people to know this also. A top-down parser generates what? Rightmost derivation or rightmost derivation in reverse, leftmost derivation or leftmost derivation in reverse. Before that, parser means syntax analyzer. What is the input for the parser? It is nothing but a stream of tokens. Taking the stream of tokens as input, it generates a parse tree, right? So how the parse tree is generated by the parser? That is the question now. How the top-down parser generates a parse tree? I have told this point and I told you to remember this also. Can anyone answer in the chat box? Yeah, top-down parser generates leftmost derivation. I hope you all know what is leftmost derivation. Leftmost derivation is nothing but deriving the string every time replacing the leftmost variable from the start symbol of the grammar. So a top-down parser generates leftmost derivation. A bottom-up parser generates what? These 2 points you must remember. This is the basics. Then only you can connect the rest of the things logically. A bottom-up parser generates rightmost derivation. But why the word is reverse? Because bottom-up parser is generating the string in such a way that string is given to the parser. From the string, it checks that whether it is being reduced to the start symbol of the grammar. So a parse tree generation happens from the leaves to the root of the parse tree. That is why we say that it is generating the rightmost derivation, but in reverse. Okay, so this you have to know. Next, I want you to take down this question. In fact, I have given the answer. Please don't look into the answer right now. First, we do the answers now. Take down the question. Question is, find the first set for the given grammar. Copy the grammar without any mistake. I think you all have copied the grammar. So now for the given grammar, we are going to compute the first set. So what is the first set? First, apart from the rules, we try to understand it. What is the first set? See, from the given grammar symbol or from the given variable or the non-terminal, when you try to derive some string, what is the first terminal symbol we come across? That is going to be the first symbol of that grammar, right? So that is what we are going to find out now. So let me try to write it here. I cannot show the parse tree, but I will show like an equation here. First off, yes, we are going to identify. We have two alternatives for yes, isn't it? One is A, B, A, another one is B, C, A. So first let me take down A, B, A. So first off, A, B, A, in fact, I have to identify. Again, in that the very first symbol is, we know that A, which is a non-terminal, right? Go for A. Again, A has two alternatives. One is C, B, C, D, another one is epsilon, right? So now, since first of S is first of A, now we are supposed to find first of C, B, C, D. Now we have identified the very first terminal, which is C. So C is one of the terminals which belongs to the first set of yes, right? At the same time, look into the alternatives of A. A has two alternatives, right? Now A produces epsilon also. If A produces epsilon, doesn't mean that first set of yes contains epsilon. First set of yes contains epsilon only if yes directly produces epsilon like this, or the rule says if all the symbols on the right hand side is all are variables and every variable produces epsilon, by the way, indirectly S produces epsilon. In that case only, first set of S contains epsilon. I hope you would have understood the rules, whatever I'm telling. First set of a symbol, whether it is S or A or B, according to this example, it can include directly epsilon only if it produces epsilon, like this in the grammar. It should contain the rule like this. Then first set of S also contains epsilon. Or yes indirectly produces epsilon. How it will indirectly produces epsilon? Yes derives, there is a sequence of variable, and if every variable produces epsilon, S also produces epsilon. By the way, first set of S contains epsilon, right? So as per this rule, this is how. Okay, now since A produces epsilon, we cannot include epsilon as first set of S. So what do we need to do? Replace this A by epsilon now. Replace this A by epsilon. If you replace this A by epsilon, what is first of S? First of S is nothing but it is first of B. So first of B. So what is first of B? Again, B has two alternatives, right? One is first of C. First we explore one of the alternative, which is first of C. So what is first of C? Again, C in turn has two alternatives, which includes E as well as epsilon. E as well as epsilon, isn't it? So what do we do now? Now first set of yes includes in fact E. I will write it here. First set of yes includes C as well as E. As of now, it cannot include this epsilon because C produces epsilon. If C produces epsilon, what do you need to do? The C must be replaced by epsilon. If you replace the C by epsilon, now you see what is the grammar now? First of B is D, isn't it? So first of B contains D. Now look into the other alternative of B. First of B is A also. Right? Okay, now I replace the grammar as such. I think earlier here I was having. Once again, I share one more document with you people. Can you see this? If you are able to see this, please say yes in the chat box so that I can continue to explain. Yes, you are able to see this, fine. Okay. Now the same grammar only I have considered. In fact, we identified first of S as A, B, C, D, E. You have the grammar at your hand. Now look into the parse trees one by one. First, look into the parse tree, which I have called it as figure 1. Right? Start from the symbol yes. Yes can be replaced by the alternative A, B, A. A can be replaced by the alternative C, B, C, D, isn't it? In fact, the C is a terminal. That is why we have included the C in the first set of yes. Whichever the terminal I have circled is included in the first set of yes. Now, come to the figure 2. This parse tree is a figure 2. Right? Again, derivation starts from yes. Yes is replaced by A, B, A. Now we are exploring the other alternative of A. What is the other alternative of A? It is epsilon. If A is replaced by epsilon, what is first of yes? First of yes must be derived from first of B. So B has two alternatives again, I think. One is C, D, A, right? Again, since C is a variable, from C you should continue to derive, isn't it? So what is the alternative for C here? I think now we discussed, right? EC. So E also belongs to the first set of yes. Okay. Now the same C is replaced by epsilon now. If it is replaced by epsilon, look into the figure 3 now. If it is replaced by epsilon, what happens now? First of yes is first of B, of course, because A is replaced by epsilon. First of B is C. Since C is replaced by epsilon, what is the first of yes now? It is nothing but D. So D is also included in the first set of yes. So C, E, and D, all these terminals are included in the first set of yes. I hope till this you have understood. Shall I proceed now further? Yes, okay. Now I'll continue to proceed now. Now you see, we are exploring the other alternative of B now. Till now we have explored the first alternative of B. Please look into the grammar. We are going to explore the other alternative of B. B can be replaced by AD in your parse tree. So first of S is first of B is nothing but A. So A is also included in your first set of yes. Now come to the last parse tree, which begins from S, right? We are exploring the second alternative of yes. The second alternative of yes says it could be replaced by B, C, A. So first set of yes can contain B also. I hope you have understood both the parse trees now. By the way, the first set of yes includes A, B, C, D, E, all the symbols. If you want, let us go through the parse tree once again. Shall we go through the parse trees once again? Look into the figure 1. Look into the figure 1. We have started constructing the parse tree from S. We have replaced it by the very first alternative A, B, A of yes. Again, A is replaced by the very first alternative, which is C, B, C, D. The C is the terminal, so first of yes included C. Now this A is replaced by the second alternative, which is epsilon, right? After that, first of yes becomes first of B. So now B is replaced by CDA. Again, since C is a variable, we are exploring the alternatives of C. Again, C has two alternatives. One is EC, another one is epsilon. We have to explore both the alternatives. As per the first alternative, we have understood that E includes in the first set of yes. Now move on to the figure 3. Since C is replaced by epsilon, We have understood that first of S is first of B. First of B is this D. D is also included in our first set of S. Just a minute, students. Yes. Now look into the figure 4. Now we are exploring the second alternative of B, which is replaced by AD. By the way, first set of B contained A. Now we are going with the second alternative of S. By the way, B is also included in the first set of S. I'm just going as slow as possible because you should not do any mistake in this. If you compute the first set and the follow set very properly, then only building the parser, you will not be doing any mistake in that. So learn to the core. Okay, now I move on to the question now. I think here earlier the grammar was containing A. Here it was containing the variable C. Am I right? I think the question is correct. Okay. Now you try to identify what is first of A. It is quick. You can easily identify. What is first of A? First of A is, as per the first alternative, it is the terminal C. As per the second alternative, it is epsilon. Right? Similarly, tell me what is first of B. Now I won't spend much time because I have explained with parse tree now. What is first of B? Again, here you have two alternatives. As per the first alternative, again C is having two alternatives. One is E, another one is epsilon. So first you have to include E, and the C must be replaced by epsilon. If you replace C by epsilon, what will become first of B? It includes D. Am I right? So as per the first alternative, we have two symbols. One is E, another one is D. Now let us explore the second alternative of B. It includes A. So A, D, E is in the first set of B. Now let us move on to what is the first set of C. What is first set of C? Two alternatives are there. C produces epsilon, so it includes epsilon. As per the first alternative, E is also present in the first set of C. What is the first set of D? First set of D, you can quickly answer. It is nothing but B as well as A. I hope you have understood this. Please have a practice of framing a table when you are answering. That is why I also have put a table. Whenever the question is asked to you, while answering, you have to display a table like this. Is there any doubt in identifying the follow set? Shall we recollect the rules? While finding the first rule, first of any terminal symbol is the terminal symbol itself. If the variable produces epsilon directly, then the first set of that variable contains that epsilon. This is the second rule. And the next rule, if a variable indirectly produces epsilon, it means on the right hand side. For example, if I have on the left hand side yes, on the right hand side, I'll give that example here. Yes derives A, B, C. Consider a production rule of this type. Now assume that A produces epsilon, B produces epsilon, and C also derives epsilon. Then in this case, I can say first set of S includes epsilon, right? This is the other rule. So keeping all these rules in mind, you can easily identify the first set. I hope this problem is clear. I have taken a different problem apart from the videos. So in the videos also, whatever the problems is given, you please practice it. Now let us move on to the next question. Before that, let me simply remind you the rules to compute follow. Is it visible for you? The rules, whatever I have given. The very first rule is, by default, you have to include the dollar symbol in the follow set of the S, which is the start symbol of the grammar. And the second rule says that every production rule you have to match with this format. The format is A derives alpha, B, beta. And you look into the formula. Every time, what is the follow set you are trying to obtain? You are trying to obtain the follow set of B. You are trying to obtain the follow set of B. If there is beta following B, then follow of B is equal to first of beta. That is the second rule. You can easily remember it. What the third rule says? The third rule says A derives alpha B. Either the rule can be of this format or the rule can be of alpha B beta, but beta produces epsilon. How do we know that beta produces epsilon? Because the first set of beta would be containing the epsilon. It means the beta can be replaced by epsilon. By the way, beta vanishes. And once again, you are obtaining the rule format alpha B. If the rule is of the format alpha B, then what is follow of B? Follow of B is equal to, sorry, it's not first of beta, it is follow of A. Follow of A. Follow of B is equal to follow of A. After B, if there is no symbols to follow, from here you directly move on to the head of the production rule. Follow of B is equal to follow of A. So these are the three rules simply you need to remember. Now you take down the second question. For this grammar, we are going to compute both first as well as the follow set. Without any mistake, you please copy down the grammar. I hope you have copied. So you have to draw the table like this. We are going to compute first function first. Later only we have to compute follow. Better draw a table like this. Okay, now we are going to find the first set for all the variables here. First of yes, it's seeming to be a little complex, so let us come to this at last. First, you tell me what is first of A. First of A is the terminal A as well as epsilon. First of B is the terminal B and epsilon. It's easy, right? First of C contains only C. What is first of D? It is D as well as epsilon. What is first of E? It is also E as well as epsilon. So we have computed A, B, C, D. Now let's move on to first of S. Better you can draw the parse tree in your notebook. What is first of S? First of S is A. Then go to A. A has two alternatives, right? Ignore the epsilon. So what is first of S containing? First of S is containing A. isn't it? What is the other alternative for A? A produces epsilon. If A produces epsilon, replace A by epsilon. Now tell me what is first of S. First of S is nothing but first of B. First of B means go to first of B. It has two alternatives again. One is B, another one is epsilon. Include B. Now replace B by epsilon. Tell me what is first of S now. First of S is what? First of C. Go to C. What is the alternative for C? It is just the terminal C. So first of S contains C. Right? That's all. First of S contains A, B, and C. We have computed first set for all the variables. Is there any doubt in this? Is there any doubt in this? Shall I proceed? Okay. Now let us start computing the follow set. For the start symbol of the grammar, by default, I have to include the dollar. So S is the start symbol for this given grammar. So follow set of S contains dollar, right? Now, I have to select or search for the rules in my grammar which has S on the right hand side. Can you find any rule as of now? No. We don't have any rule which has S on the right hand side of the production rule. So further, nothing to explore about follow set of S. So follow set of S contains only dollar. Have you got it? Okay. Now we are going to compute follow set of A. So I will write it here. We are going to find now follow set of A. To compute follow set of A, I have to select the rule which has A on the right hand side. So which is the rule I have to select? Yes, derives A, B, C, D, E. This is the rule I have to select to find the follow set of A, because I have to identify which are the symbols following A in my production rule. That is the purpose of computing the follow function. Okay. Now I have to match this rule against this format. Can you see this box? A derives alpha, B beta. See here carefully how I'm matching this. Yes is matched against A. For which symbol we are going to compute follow? For A. So A should be matched with this B. And following A, whatever is there should be matched with beta, B, C, D, E. Have you understood this? This is the way you have to match your rule with the defined pattern. What is a defined pattern here? A derives alpha, B, beta. And remember that every time we are trying to attempt follow of B, this B is, as per our rule, it is A, right? So follow of A, we are going to compute. Now recollect the rule. If there is beta, follow of B is first of beta. It is the second rule. Am I right? I'll just display once again the rules here. We have matched our rule against this format. We are trying to compute the follow set of B. If there is some symbol following that B, so what is the rule says? Follow of B is equal to first of beta. That is the rule says. I'll just copy this. So the rule says follow of B is equal to first of beta. So what is B here? What is B here? B is nothing but A. Am I right? What is beta here? It is nothing but B, C, D, E. Once again, among B, C, D, E, which is the first symbol? It is nothing but B, right? Now go to first of B. What is first of B? We already identified and kept, which is B comma epsilon. So consider that B comma epsilon. Epsilon, I will write it as epsilon itself here. B comma epsilon. One point I would like to remind you here, the first set may contain epsilon, but the follow set should not contain epsilon. epsilon never ever appears in the follow set of any symbol. Okay, but follow of A we identified as first of B, but first of B contains epsilon. So what to do now? First, we will include follow of A as B now. I will write it here. Please check the table. Follow of A contains this B. There is no doubt in that. But it contains epsilon also, but I cannot write epsilon here. So what do? I should replace this B by epsilon in my rule. If I replace this B by epsilon, now you tell me what is follow of A. Can you tell me now? Follow of A is nothing but first of C. Follow of A is nothing but first of C. What is first of C? It is just a C. So include that C also in the follow set of A. Yes, we have identified the follow set of A. Is there any doubt in this? Shall I proceed to the next thing? Shall I proceed? I'm waiting for your reply. Okay, very good. Few people are answering yes. Okay, now we have finished computing follow of A. Now let us compute follow of B. Let us compute follow of B. So accordingly, I modify it here. Follow of B, right? So follow of B I have to compute means, how do I write the rule here? B should appear here. C, D, E should come here. E should appear here. Have you understand the way I have matched the pattern, the rule, right? Now this alpha is nothing but A. For this B only we are going to identify the follow set. That is why this B is matched with B itself. After B, whatever comes is assumed as beta. Now, since after B, there are certain symbols following, the rule is the same. Follow of B is equal to first of beta, right? So, B is nothing but B itself here. What is beta here in fact? Beta is C, D, E. Am I right? So, what is the first of CDE? It is first of CDE is in fact first of C. What is first of C? In fact, it is C. All right. So, follow of B is first of C, which is equal to C. So, follow of B contains only C. I hope you have understood this. Shall we continue to proceed a follow set of C now? Is there any doubt? Okay, now let me compute the next follow set of C now. Follow set of C. Accordingly, you try to modify the pattern of the rule. Alpha contains AB. For C only, we have to compute the follow set. So write C here. Now this is in fact containing DE. Right? Okay. Now how do we identify? Follow of C is equal to first of beta. That is the rule we have to apply. So follow of C is first of DE. First of DE is in fact it is nothing but first of D. What is first of D? It is D comma epsilon, isn't it? So I have written as it is. I'll just erase the next line. Let me type it once again. So follow of C is first of D. First of D is, we already identified D and epsilon. So follow of C contains D. I cannot include epsilon. If I should not include epsilon, what do I need to do? I have to look into the box carefully now. I am replacing this D by epsilon. Now tell me what is follow of C. Follow of C is now First of D, isn't it? First of E. What is first of E? It is identified as E comma epsilon. Just I'll copy and paste it here. Right, so first of E is E, but once again I cannot include epsilon. If at all I should not include epsilon, what is the thing I have to do? I have to replace this E by epsilon, isn't it? Now look into the rule. What is the rule we have? A, B, C only is there. We are trying to identify follow of C, but there are no symbols following it. If there are no symbols following it, what I said, move on to the start symbol. I mean, not the start symbol, head of the production rule. Now tell me what is follow of C. You have to exercise the third rule now. Follow of C is equal to follow of A. Look into the third rule. I'll just show you the third rule. If your production rule is of the form A derives alpha B, it means there is no beta here. Or if this beta is replaced by epsilon, what the rule says, follow of B is equal to follow of A. If I apply the rule here, what is the rule I will be getting? Follow of C is equal to follow of yes. So follow of C is equal to follow of yes means I have to include the symbol dollar here. Have you understood this? Or do you expect me to repeat this once again? Students, have you understood this? Okay. Shall we proceed on to the next thing? Only few students are listening. Please be active in the classes. Finally, you people are going to be the sufferers if you don't understand it. So stay active. It's very important. Later, you people should not regret. Okay, thank you. Now I'm getting the response. Okay, now, next we are going to compute the follow set of D, right? So if we are going to compute the follow set of D, how do I match the rule? Alpha contains A, B, C. We are going to compute follow of D. So D should be matched against the B. What is there in the beta? It is E, right? So I'll delete this. You people do it simultaneously. I will also give the answer. And you try to reply the answer in the chat box. Yeah, some of you have replied the answer. Very good. I hope you are understanding, because teaching something in board is different and doing it in online classes is different. So I'm trying to give you the maximum effort. If you have understood, I'm very much happy. Okay, follow of D is equal to first of E. This is the way the rule is to be matched. First of E contains E comma epsilon. So follow of D must contain E. Right? Since the first set of E contains epsilon, what do you need to do in the rule? What is the modification you have to do? This E must be replaced by epsilon. Now look into the rule. Follow of D is equal to follow of yes. So by the way, we have to include the dollar symbol. So E comma dollar is the right answer. Similarly, tell me what is follow of E. follow of E, if you try to compute follow of E, actually after E there is no symbol to follow. So follow of E is equal to follow of S, which is nothing but dollar. Very good. You people are answering. I hope you will not be getting any doubt in computing the first and the follow set. This is a way you need to solve. Practice the problems. I'm giving you an exercise. Please take down this exercise. This you have to solve later, not now, but just copy down the question. Okay, I hope you have copied the question. Now take down the heading LL1 parser. LL1 parser. It's a top-down parser. This parser is able to parse a good number of context-free languages. We need context-free languages to define the syntax of our program, right? So you should know the purpose. Whenever I say something, you should be able to link so many things. LL1 parser is a top-down parser. This parser is able to operate on a good number of context-free languages. Why context-free languages in the syntax analysis? Because context-free languages is able to define the syntactical structure of the languages. It is able to define how an expression should be. It is able to define how an if statement of a language must be. Context-free languages is able to define what is the syntax for while loop, what is the syntax for loop. So in general, context-free language is suitable for defining the syntax of the programming languages. Okay. Now we try to understand the meaning of the name LL, also the meaning of this one also. First L stands for left to right scanning. Already we have discussed this. Left to right scanning means it is nothing but the program is read by the compiler, which is kept in the input buffer from left to right, character by character. That is why left to right scan. And the second L stands for leftmost derivation, because it is a top-down parser, right? Already I said it is deriving the string and the leftmost derivation. So second L stands for leftmost derivation. What is the meaning of this one? When the parser is parsing the string, when it is deriving the string from the grammar, how we derive the string manually, we just try to choose out from the alternatives, right? Okay, this rule may lead to the derivation of the string. Suppose a variable has two alternatives, we will be trying to choose from those alternatives. So parser also has to do that. So to choose out from the alternatives, it always looks one symbol ahead. To indicate that only, the number is given as LL1 parser. In general, we have LLK parser where K indicates the number of symbols it looks ahead. But in our syllabus, we have LL1 parser, which always looks ahead one symbol and tries to parse the string. That is the meaning of LL1 parser. Now take down this question. Construct LL1 parser for the following grammar. Construct LL1 parser for the following grammar. This grammar you are very well aware, right? Okay, now I want to remind you the important points now. When the question is asked to you like this, you cannot build a LL1 parser on this grammar because this grammar is ambiguous. Which grammar is suitable for top-down parsing? The grammar which is unambiguous, the grammar which is free from left recursion is suitable for top-down parsing. So to confuse you, either they will give you this grammar or sometimes they will give you this grammar to construct LL1 parser. Any form of grammar is given, make sure that it is unambiguous and there is no left recursion. Okay, that is why I have given in the steps. This is expression grammar, this is also expression grammar. All are equivalent to each other, only that this is unambiguous and this is free from left recursion. Okay, unambiguous grammar already we discussed. After removing left recursion, I just want to write the grammar. E derives T dash. What is the next rule? We have to say what is E dash. E dash derives plus T E dash R epsilon. Then we have to, this rule is again left recursive, so we have to remove left recursion from here. T derives F T dash. The next rule is T dash derives star F T dash R epsilon. The last rule there is nothing to modify because it's not left recursive, right? F derives E or ID. We have to retain as it is. I'll just show you the grammar now. Now this grammar is suitable for top-down parsing. This grammar is suitable for top-down parsing. Okay. Now with this grammar only you can construct LL1 parser. Suppose the question is asked with the previous grammar, you have to convert to this grammar, then only you have to continue to do. Now you take down steps to design LL1 parser. Steps to design LL1 parser. First step is computing first and follow. Computing first and follow. Second step is constructing LL1 parsing table. Constructing LL1 parsing table. I'll show you how it is. Yeah, it looks like this. Constructing LL1 parsing table. And the third step is parse the given string. String will be asked in the question. So you have to parse and show the given string. These are the three steps. These are the three steps you have to do to solve the problem. Second step is constructing LL1 parsing table, and the third step is parse the given string. Okay, now I'm not going to find a first and follow. I'm directly going to give you the answer. Please try this problem. We will effectively discuss in the next class. I want to move on to the next step. So you please copy this. Please copy the first and follow for the given grammar. You try to solve it on your own along with one more exercise I have given. If you have any doubt, we will discuss this in the next class. I want to move on to the second step now. Students, if you have copied, let me know. Yes, Shweta, it's dollar symbol. Dollar as well as the close parenthesis. Here also dollar as well as close parenthesis. For T, we have plus dollar and close parenthesis. Okay, fine. Now let's move on to the second step now. Yeah, let's move on to the second step. I think T dash contained only the plus dollar as well as close parenthesis. There is no star here. Star is present only in the follow set of yes. So please make that correction. Dollar, close parenthesis, as well as star. I think so. Anyhow, I'll correct if any mistake is there. Okay. Now we are going to learn how to fill this parsing table. Right? I just erase all these things. I'll just fill and show you in front of you people. So to fill this parsing table, I need three things. I should know the grammar, and the first step is over by this time. See, this is the signature of the table. M of A comma A is the signature of the table. If you remember this, then you know what is row and what is column, right? M refers to the parser, machine. Normally PDA and all we refer by M, right? The same letter here also it is used. M refers to the machine. And the first symbol A refers to the variable. Rows represent all the variables and the columns represent all the terminals. So what are the terminals present in the grammar? We have plus, we have star, we have open parenthesis, we have close parenthesis, and ID is also the terminal. Along with all the terminals, every parsing table should include the dollar sign also, because dollar is the right-hand marker of the input. For example, ID plus ID star ID is available in your input buffer, you imagine, right? So dollar indicates the end of the string. ID plus ID star ID, after that, you should write dollar in the input buffer. So dollar is the right-hand marker which indicates the end of the string. So in every parsing table, apart from the terminals, you have to include the dollar also. Now let us learn how to fill the table. Consider the very first row value, which is E. What is first of E? First of E is nothing but this open parenthesis as well as ID. At the same time, look into the rule for E. What is the rule for E? It is nothing but TE dash. So E derives TE dash. I have to fill this rule in the first set of E. So first set of E already we computed. So I have to fill this rule. Control C. E derives TE dash against these symbols. E comma open parenthesis will contain this rule, as well as E comma ID also will contain this rule. Have you understood this? How I filled this? Okay. Now let us move on to the next rule. E dash derives plus TE dash or epsilon. I must know where to fill this rule, okay? E dash, first you consider what is first of E dash. First of E dash is plus as well as epsilon. Now I should consider only plus. If epsilon is there in the first set, I should move on to the follow set, okay? If the first set does not contain epsilon, there is no need for me to consider the follow set. Have you understood this? Okay, now I'm considering the second rule. For this, to fill up the second rule in the table, first I'm considering the first of E dash. First of E dash contains plus, isn't it? Once again, E dash has two alternatives. One is plus T dash, another one is epsilon. The plus I would have obtained from the rule plus T dash, isn't it? So I should consider only that alternative. That alternative I have to fill against the row and column E dash comma plus. So E dash comma plus contains the rule E dash derives plus T dash. Okay, next question is where to fill this E dash derives epsilon. E dash derives epsilon should be filled in the follow set of E dash. Are you understanding this? So where can I fill E dash derives epsilon? E dash comma dollar, E dash comma close parenthesis. There and all I have to fill the rule E dash derives epsilon. So let me write it here. E dash derives epsilon. I have to fill in the follow set of E dash, which is dollar, and another symbol is the close parenthesis. E dash derives epsilon. I hope you had understood this. Okay, now let's move on to the next rule. T derives ft dash. Where do you fill this rule T derives ft dash? Into the first set of T. So let me, where can I write? T comma id, I should fill the rule T derives ft dash. Again T comma open parenthesis. There also I have to fill the rule T derives ft dash. I hope you had understood this. Now let us move on to the next rule. T dash derives star ft dash we have. T dash produces epsilon also. Now you can easily tell me what is first of T dash. First of T dash contains star as well as epsilon. Whenever there is epsilon, you have to consider the follow set also. So which rule where to be filled? T dash comma star. For that cell, you have to fill the rule T dash derives star ft dash. Okay, T dash produces epsilon, right? We have that rule, right? Whenever T dash produces epsilon, go to the follow set. What are the follow set symbols we have? Plus, dollar, close parenthesis. There and all you write the rule T dash derives epsilon. Again the same rule where and all I have to fill against the dollar as well as against the close parenthesis also I have to fill the rule. Right, now we have the last rule, F derives E we have, F derives ID also we have. Consider only F derives E. When the production rule is F derives E, what is the first set of F? The first set of F is only the open parenthesis, right? Just consider only the rule like this. F derives E. If the rule is F derives E, what is first of F? It is just only the open parenthesis, right? So you have to fill the rule F derives E against this open parenthesis. F derives ID. When you consider the rule, what is the first of F? It is ID. So against the cell F comma ID, I have to fill this rule. I have to fill the not E, I have to fill the rule F derives ID. So every rule is filled appropriately in the table based on the first and the follow set. When you are filling the rule, first you have to consider the first set. If the first set contains epsilon, go and consider the follow set. I hope you had understood this. Please practice first and follow as well as this parsing table as of now. For the same problem, we discuss the first and follow in the next class if you have doubt. Otherwise, we straight away go for the string parsing in the next class. I hope you all have understood. Yes, I'll